Okay, so we want to talk about target surfaces for pesticide application. So the target for pesticide droplets could be plant surfaces or insect surfaces. Now, as far as plants are concerned, they are covered by a barrier which prevents pesticide penetration. The outside layer of plants are covered by a substance known as the cuticle. The cuticle has several components. Okay, let me admit someone. Okay. So the cuticle has several components. Let us have a look at the components. You can have on the outer surface forming a boundary with the atmosphere, we have got the epicuticular wax. We also have the embedded wax, the cutiny, the pectin strand shown by those arrows. Then we have also what we call the cuticle, which involves all these other parts. Below we've got the cellulose, then the plasma membrane. For the pesticide to enter the plant, it has to go through that cuticle. Sometimes that pesticide may fail to penetrate that cuticle. Under those circumstances, the pesticide may not do its job. Anyway, these are some of the details of the pesticide. Probably when you look at your notes or PDFs, you may go into the details. But these are just the components of the cuticle for the plant. So we have the epicuticular wax or cuticle plus wax forming the outer layer. You can have the droplet which lands on that surface. Depending on the characteristics of the droplet, it may finally penetrate through the cuticle. Then it moves into the epidermis, then mesophyll layer. It may end up in the phloem or xylem root. The xylem root is the apoplastic root, and the phloem root, where you have living cells, it becomes the symplastic root. Then the pesticide may go wherever it is going to do the job. But otherwise, the cuticle may prevent it from entering the plant. So what is the cuticle? It may consist of a cutiny, which is nonpolar. It forms sponge-like lattice. It is cross-linked polymer of various hydroxy and carboxylic acids, which are insoluble in most solvents. Then the cuticular wax. The wax is composed of straight-chain alkanes or alkanes carrying hydroxyl or carboxyl groups. The hydrocarbons contain an odd number of carbon atoms. These could be 21 and 35 altogether. The acids and alcohols contain even numbers. This could be 20 to 24. So the outermost layer of the cuticle is wax. Otherwise, I was now describing probably the chemistry of the cuticular wax. So this is the wax. It can have 27 carbon atoms or 25. It could be 26 carbon atoms. Now on the plant we can have stomata trichomes. These are structures on the plant. The stomata trichomes are hairs and hydathodes channels. These are intrusive structures in the cuticle of most leaves. They can pass through the cuticle. Hydathodes, these are the passage of water out of the plant, and they may not be used by the pesticide to enter the living systems. The hairs could trap pesticides and therefore could prevent the entry of the pesticide in the plant. The stomata do not form part of the entry points, although these are openings on the plants. So they don't form the passage of these aqueous pesticides. However, pesticides could enter through sensitive gut cells, which are part of the stomata. So we can have hydrophilic and hydrophobic properties, which are balanced in within this within the plant. So if we look at the entry of pesticides into the plant, the degree of pesticide penetration can vary depending on the plants. Some may not go very far. This could be quasi-systemic. Although they enter the plant, they may not go very far. We may also have superficial deposits possessing an entry contact action, something which remains on the plant surface. Or we could have systemic pesticides which could penetrate right through the cuticle and get transported around the plant. Please note that there are lipoprotein membranes which could prevent pesticide entry. So that was the protection of the plant from pesticides, the cuticle. What about the insect? The insects pests may have what they call the integument, which also looks like what the plants have. So the insects also have this cuticle. We have the epicuticle and the endocuticle. But anyway, as long as you note that there is the presence of this cuticle with the various parts which can prevent the entry of the pesticide, so that it can reach these living cells and cause damage. So there's a protection area. So this is the epicuticle. This is the outer surface. Then you have got the whole layer of the cuticle, which can prevent pesticide entry into the insect. Here I've got also some details which you can check in your PDFs for the structure, for the detailed structure of the cuticle for insects. Again, these are some of the details, but what we know is that we have a cuticle which prevent entry of pesticides into the insect pest. So the outermost layer of the insect is known as the epidermis. It separates the cuticle. The cuticle and the epidermis are known as the integument, that is the part of the insect. The cuticle covers the exterior part. It's rich in protein, inner layer, glycoproteins, chitin and tannin agents. That is the inner layer or the inner part. Then the epicuticle, the outer layer, as opposed to the inner layer, is rich in lipids and lipoprotein. Then we have something called the procuticle. This is secreted by the epidermal cells. That is 90% of the cuticle. Then we have got the chitin, which is 60% water-soluble polymer, N-acetyl glucosamine. That is the chitin. There are at least 3 kinds of chitin: hydrophilic inner region of the endocuticle and the other lipophilic outer exocuticle. The exocuticle contains melanin. Sclerotin is responsible for cuticular rigidity in beetroots. It stabilizes this cuticle. There's also presence of sensory cells in the exocuticular region. The nervous system is intimate target of many particles. Waxes, sorry for that. Hello? Ndiri mu lecture. The waxes are innate. Actually, they prevent the entry of pesticides, and they can cause selectivity. Then the inner layer of epicuticle is penetrated by wax canals. So waxes can prevent entry of pesticides inside the insect and protect it. So what we should note is that the cuticle is the first line of defense against the entry of pesticides and the xenobiotics into the plants and insects. And to some extent, the cuticle can cause a resistance to the insect, to the pesticides, either in plants or in insect pests. So this is it on the cuticle, which is an important barrier to pesticides and is the first line of defense for insect pests and weeds. So let me stop here.